In this lab, we look at the printing firm data collected. A printing firm wishes to estimate the time taken to print a large job of 18,000 posters and has the following data from 10 previous jobs. The firm's estimator feels that there should be a strong positive linear relationship between time and quantity. So these are the data collected. So quantity in thousands and time in hours. So first let's arrange this data in column form. So we have the data arranged in column form here. And then let's input the data and find the correlation coefficient between time and quantity. Is it consistent with the estimator's initial option above? So we want to calculate the correlation coefficient. So we type equal correl and we select the time, comma, and then the independent values for the quantity, close the bracket, and we get minus 0.2398 and so on. This negative sign, it shows that it is negative relationship. So it is not consistent with the estimator's opinion. Carry out the regression analysis, write down the equation of the regression line and use it to predict the time to print 18,000 sheets. Comment briefly on the prediction and the suitability of this regression. So let's type equal in an empty cell and line est. So that's line estimation. Let's put the dependent values. Which is for time, comma, then the independent variable values for quantity and close the bracket. It gives us the coefficient values and the intercept. So the equation is time equal 2.585 minus 0.142 times quantity. So we have rounded the coefficients to 3 decimal places. The quantity is in thousands and the time is in hours. So let's predict the time for all the quantities, including 18,000 sheets. So equal 2.585 minus 0.142 times the quantity. And let's copy the formula to all the other cells to be predicted. Now let's plot the spreadsheet. So in an empty cell, click on in an empty cell and then click insert, click on chart. Then for the chart type, click the scatter plot. Okay, let's take the chart to a new sheet. So move to on sheet and let's edit the chart. For the data range, let's do the selection for the data range. So first let's select the quantity. Then let's select the time. And let's select the predicted time. Press on OK. And for the so we have the red dot showing the prediction, and the observed values are in blue. So let's customize the chart. For the horizontal axis, let's type the minimum and maximum values. So let's type 1.8 for the minimum and maximum 18.2. And for the vertical axis, let's select the minimum value to be minus 0.2. And the maximum value, let's select, say, 6.2. Now we can see the outlier is for the quantity to 2000 sheets and the time is 6 hours. So that actually there was positive relationship, but then due to this outlier, it shows that the intercept is more attracted to this outlier. Okay, so now predict the time to print 18,000 sheets. So we have done that, and which is about 0.029 hours. Explain why this analysis is giving such peculiar answers. Decide what action is needed and carry this out. If you are having difficulty deciding, plot the data and look for anything unusual. So the outlier is having a major effect on calculations. We need to remove it. As you can see in this chart, the outlier at quantity 2000 sheet and time 6 hours is having an effect. So now we want to remove that value. So this is the new data. Let's do that. Let's copy this table. Let's copy that here. And then we want to remove this outlier. So we want to remove this quantity 2 and time 6 hours. So now we are left with this. So now if we plot that in an empty cell, click in an empty cell, click on Insert, click on Chart, and move this chart to a new sheet, to our sheet. Click on Edit Chart, and let's select the data range. So the data range, let's add the quantity values. Then let's add the time values. And let's add the predicted time. So for the series, there is predicted time plotted. Let's add another time in hours. Okay, so now what happens is that predicted time. So explain why this analysis is giving, so repeat. So when we remove the data, okay, so we need to find the equation again. So the outlier is having a major effect on calculations. We removed it. Then we repeat steps A and B above. Are you getting more sensible answers now? So for the correlation coefficient, we type equal correl of first the dependent values, comma, then the independent values, and close the bracket. That's 0.907. Now this is very close to 1, which is showing a strong positive relationship, which is consistent with the estimator's opinion. Now we want the regression equation. So for the regression equation, let's find the regression equation. So equal linest, first the dependent values, then the independent values, close the bracket. So the regression equation is time equals 0.152 plus 0.186 times quantity. We have rounded the coefficient values to 3 decimal places. The quantity is in thousands and the time is in hours. So we use this to calculate the predicted values. So equal 0.152 plus 0.186 times quantity. And we copy this formula to all the other cells, including quantity 18. And then in the spreadsheet, we see the changes automatically being done. And now if we look at this predicted time and the observed values, that is they are more look like consistent, that is in the positive linear relationship. And for 18, the predicted value, this is called extrapolation because it's not within the range of the observed values. Okay, so now we interpret each coefficient of the new regression equation in the context of this question. 0.152 hour is the intercept, and that represents the setup time for machine. And each extra 1000 sheets takes 0.186 hour. Predict the time taken to print 5,000 and 18,000 sheets. Comment on the accuracy of each equation. So 18,000 sheets and 5,000 sheets. So for 5,000 sheets, we type equal 0.152 plus 0.186 times 5, and that's 1.082 hour. And for 18,000 sheet, we type equal 0.152 plus 0.186 times 18, and that's 3.5 hours. Now we show that in the chart. Let's edit the chart. Let's add the value 5. So let's choose the data again. Let's select the data range, fetch the quantity, then add another range, the dependent value, which is time, then add another range, which is the predicted time. Okay, so now let's mark these predicted time values for 5,000 sheets. Let's color that differently. No, that was red. We just want to color one particular this circle over here, this bullet point. So by clicking on it, we can color that. And we also want to color this predicted time for 18,000 sheet. So click on that circle, and this format data point comes up. So color that orange. So now for 5, its interpolation is reliable with the observed values, and thus 18,000 sheet, this predicted time is extrapolation, and it's unreliable with the observed values. Now what happens is that 18,000 sheet is away from it's not being observed yet, so that's why it's not within the range of the observed values, the observed quantity. So that's why it's extrapolation. And for 5,000 sheet, it's within the range of the observed quantity values. So that's interpolation. So 1.082 hour, next for 5,000 sheet is reliable and it's interpolation, and 3.5 hour is unreliable and extrapolation.